Hello everyone. My name is Papri Ghosh. I am assistant professor from CSE Data Science Department. So today we are going to discuss about queue. So what is queue? Queue is a linear data structure where elements are added at the rear and removed from the front. So a queue can be defined as an ordered list which enables insert operations to be performed at one end and delete operation to be performed at another end. So when we are going to do the insert operations, so that end the elements are inserted to that at an one end, it's called rear. That means insert operations to be performed at one end is called rear and delete operation to be performed at another end is called front. So queue is referred to be as first in, first out list. So it maintains the FIFO principle. What is the meaning of FIFO principle? Let's assume we want to catch any buses and we know the bus timing and then we are waiting for the bus. So let's assume first I came, after that my another friend came. So as I came first, I will go to the bus first. So that is called first in, first out. Okay, you can say last in, last out. Okay, the first element inserted is the first one to be removed. First in, first out means the first element inserted is the first one to be removed, or first come, first serve principle. So that is called queue. And complexity of queue, you can say it is an insert. We'll discuss later what is the complexity of an queue. So queue also be defined as a list of collection like there are four types of queue. One is simple queue, linear queue. Second one is circular queue. Third one is priority queue, and fourth one is double-ended queue. What is simple queue? In linear queue, an insertion takes place from one end while deletion occurs from another end. The end at which the insertion takes place is known as the rear end, and the end at which the deletion takes place is known as the front end. It strictly follows the FIFO rule. The major drawback of using linear queue is that insertion is done only from the rear end. If the first three elements are deleted from the queue, we cannot insert more elements even though the space is available in linear queue. Okay, and in this case, the linear queue shows overflow condition as the rear is pointing to the last element of the queue. So, insertion of an element in a queue is called in queue, and deletion of an element in the queue is called dequeue. First, we are going to discuss what is circular queue, double queue, and priority queue. Then we are coming to this point. In circular queue, all the nodes are represented as circular. It is similar to the linear queue, except that the last element of the queue is connected to the first element. It is also known as ring buffer, as all the ends are connected to another end. The drawback that occurs in linear queue is overcome by using the circular queue. If the empty space is available in circular queue, the new element can be added in an empty space by simply incrementing the value of rear. The main advantage of using the circular queue is better memory utilization. Next is priority queue. Priority queue is a special type of queue in which the elements are arranged based on the priority. It is a special type of queue data structure in which every element has a priority associated with it. Suppose some elements occur with the same priority, they will be arranged according to the FIFO principle. The representation of it is like a ring. So insertion in priority queue takes place based on the arrival, while deletion in the priority queue occurs based on priority. Priority queue is mainly used to implement CPU scheduling algorithm. Next is DQ. It is called double-ended queue. Double-ended queue insertion and deletion can be done from both ends of the queue, either from the front or rear. It means that we can insert and delete elements from both front and rear ends of the queue. DQ can be used as palindrome checker, means that if we read the string from both ends, then the string will be the same. DQ can be used both as stack and queue, as it allows the insertion and deletion operation on both ends. DQ can be considered as stack because stack follows LIFO, last in first out principle, in which insertion and deletion both can be performed only from one end. And in DQ, it is possible to perform both insertion and deletion from one end. DQ doesn't follow FIFO principle. So operation performed on queue is called NQ, DQ, peak, queue overflow and queue underflow. First we have to understand what is NQ. NQ operation is used to insert the element at the rear end of the queue. It returns what? DQ. DQ means deletion of an element from the queue. It performs a deletion from the front end of the queue. It also returns the element which has been removed from the front end. It returns an integer value. Peak. This is the third operation that returns the element which is pointed by the front pointer and in the queue, but doesn't delete it. And queue overflow. Queue overflow is when the font and queue overflow means the overflow condition of queue. When the queue is completely full, then queue overflow occurs. And when the queue is empty, then the queue underflow condition occurs. So, what is queue overflow and what is queue underflow? So, when we are going to insert an element, then we just increase the rear, the value of the rear. Okay, and when we want to delete any element from the queue, then just front is increased by 1. So when we are accessing the total number of, we want to know what is the total number of elements in a queue, then we use this function rear minus front plus 1. Insertion, NQ. So NQ is a function, Q is the queue and N is the size of the queue and F is front, R is rear and I tail. So if R equal to N minus 1, that means let's assume the size of Q is 8. So we have started 0 to 7. When we are inserting first element at 0th position, then when we want to insert any element, so then the rear part will be increased and front will point 0th position. Okay. Then if R equal to the value of rear is 7, that means the queue is full, and queue is full means queue overflow. The overflow condition will occur. So if R equal to N minus 1, write overflow, and if F equal to minus 1, that means Q is empty. Set F equal to 0 and R equal to 0. Okay, and if the front is 0, but rare is any other value, then we are going to increase the value of rare. So QR equal to item and rare equal to rare plus 1. That is the operation of DQ. DQ, deletion of Q. If f equal to minus 1, then under 4 condition will occur. Item equal to Q of f. If f equal to r, then set f equal to minus 1 and r equal to minus 1. Okay. Else f equal to f plus 1. That means when we want to delete any element from Q, then we are going to increase the value of front. Okay. That means we are inserting element from back end and we are deleting from an element from front end. Okay. So now consider the following sequence of operation on an empty stack: push 54, push 52, pop, push 55, push 62, and S equal to pop. And consider the following sequence of operations on an empty queue: NQ21, NQ24, DQ, NQ28, NQ32, Q is equal to DQ. What is the value of S plus Q? Okay. We are going to draw a stack. So push 54, push 52, pop. $54, $52, pop, then push 55, 62. Push 54, push 52, pop, then push 55. Okay. Push 54, then push 52, then pop, then push 55, then push 62, then S is equal to pop. So the value of S is 62, right? Because it is a stack. The value of S is 62. But next, for NQ21, NQ24, DQ. NQ21, then NQ24, then DQ. Then DQ means 21 will be deleted, right? Then NQ28, NQ32. NQ28 and NQ32. NQ28 and NQ32. Then DQ. That means Q, the value of Q is 24. So now that S plus Q means 86. So answer will be 86.